So in this notebook, I'm going to give a network of how neural network from scratch is executed. In the first cell, I set up a cell with and I import all the required libraries required for the further execution. In the next cell, this cell defines the most fundamental operation in all of deep learning, a single neuron. And we'll see how it takes input arrays, outweigh arrays, and bias, and computes the dot product of input and everything in this cell. Next, here I define an abstract class for activation functions and implement four classes, which is sigmoid, tan, and all these which are required. Yeah. Next is this cell plots all four activation functions alongside their derivatives in a 2 cross 2 grid over the input range of -5 to 5. In the next cell, I define an abstract loss base class and implement two concrete loss function, which is mean squared error for regression and binary cross entropy for binary classification. After that, then this cell sweeps a prediction from values from 0 to 1 and plots how MSE and binary cross entropy loss change for a fixed true value of 0.7. In the next cell, this is the most important cell. It implements a fully connected dense layer as a class with forward and backward methods. After that, I define an abstract optimizer base class and implement three concrete optimizers: plain SGD that subtracts the learning rate times the gradient, SGD with momentum that accumulates velocity to, and then ODM that adopts the learning rate per parameter. Next is a neural network class. This cell ties everything together by implementing the full neural network class with an add method for stacking layers. In the next cell, cell trains a neural network to solve the XOR problem, which cannot be solved by a single linear layer. Next, I plot the XOR decision boundary by creating a dense mesh grid over the input space, passing every point through the trained network and coloring each point by the predicted class. After that, in next cell generates a two moons dataset, two interleaving half circle shapes that cannot be separated by straight line, and a trainer a deeper network with multiple hidden layers to classify them. The next cell, I generate a three class spiral dataset where each class forms a twisted arm, making it one of the hardest classification problems for linear models. Next, in this cell, I plot the multi-class decision boundary for the spiral classification task using a color-coded mesh grid. The resulting plot shows the intricate curving boundaries the network learned. After that, in the next cell loads the sklearn digital dataset of 8 cross 8 grayscale images of handwritten digits, pre-processing them using a standard scaling, and trains a fully connected network to classify all 10 digits classes. After that, I display a 3 cross 5 grid of test images alongside their predicted and true labels, coloring correct prediction in green and wrong ones in red. In the last cell, the final cell is an open ended playground that invites experimentation with different architectures, activation functions, optimizers, and learning rates. And it prints example code and encourages trying combination like adding more layers or switching to SGD with momentum. So that's it with this collab. Thank you.